Imagine a world with no animals, no trees, and no humans. A world ruled entirely by microscopic life. Now imagine that this life accidentally triggers a climate catastrophe so severe that much of the planet freezes. This isn't science fiction. It happened around 2.4 billion years ago during Earth's first known ice age, the Huronian Glaciation. Long before dinosaurs or even simple animals existed, Earth was a very different place. The atmosphere contained almost no oxygen. Instead, it was rich in gases such as methane, carbon dioxide, and nitrogen. Methane was especially important because it was a powerful greenhouse gas. It trapped heat and helped keep the planet warm, even though the young sun was weaker than it is today. The only known life on Earth consisted of tiny microorganisms living in the oceans. For hundreds of millions of years, these microbes quietly evolved. Then, one group changed the planet forever. These organisms were cyanobacteria. Using sunlight, water, and carbon dioxide, they performed photosynthesis and released oxygen as a waste product. At first, this oxygen reacted with iron and other chemicals in the oceans, but eventually, those materials became saturated, and oxygen began accumulating in the atmosphere. This event is known as the Great Oxygenation Event. It was one of the most important turning points in Earth's history. But it came with a consequence. At the time, methane was helping keep the planet warm. As oxygen levels increased, it began reacting with methane in the atmosphere. These reactions converted methane into carbon dioxide and water. The problem was that methane is far more effective at trapping heat than carbon dioxide. As more methane disappeared, Earth's atmosphere lost much of its warming power. The planet began to cool. Slowly at first, then dramatically. Temperatures dropped across the globe. Ice sheets expanded. Glaciers spread across large regions of the planet. Earth had entered the Huronian Glaciation, the first known major ice age in its history. This wasn't a short cold period. The Huronian Ice Age lasted for hundreds of millions of years, making it one of the longest glacial episodes Earth has ever experienced. Vast areas of the planet were covered by ice. Today, scientists know this happened because ancient rocks preserve evidence of glaciers that existed more than 2 billion years ago. They find glacial deposits, scratched bedrock, and sediments that could only have formed in icy environments. These clues allow researchers to reconstruct a frozen world that existed long before complex life appeared. Despite the harsh conditions, life survived. Microorganisms continued living in the oceans and adapting to their changing environment. Meanwhile, oxygen continued accumulating in the atmosphere. What began as a climate disaster was also transforming Earth into a completely new world. Over time, oxygen-rich conditions would make more advanced forms of life possible. Without this transformation, complex cells, animals, plants, and eventually humans might never have evolved. But how did the Ice Age finally end? The answer came from deep within the Earth. Volcanoes continued erupting for millions of years, releasing carbon dioxide into the atmosphere. As carbon dioxide gradually built up, the greenhouse effect strengthened once again. The atmosphere began trapping more heat. Global temperatures slowly rose. The glaciers retreated. The ice melted. And Earth's first great ice age finally came to an end. The Huronian Glaciation was far more than a frozen chapter in Earth's past. It was a turning point. Life changed the atmosphere. The atmosphere changed the climate. And the climate changed the future of life. In one of the greatest twists in Earth's history, the oxygen that helped trigger the planet's first ice age would later become the foundation for all complex life. Without it, none of us would be here today.